Hey guys, hope you all are doing well. Today I am going to connect a Raspberry Pi to my Pixhawk flight controller based drone so that I can increase the computational power of my drone. And doing this I can work on OpenCV libraries and I can install robot operating system and build cool applications. So let's see. Before going for some actual connection, I would like to add that if you are a beginner and if you want to do or add an onboard computer to your drone, then I would recommend to go with such kind of frames, say RTF frames like the F450, S500, F550 or TBS Discovery's frames. So if you are having any problem with your code or anything that could go wrong, then you won't be at much loss. So there's one more drone that I'm going to use for this project. So this is custom built carbon fiber and some 3D printed parts. So the right thing here, it's 3D printed. Here you have the GPS, telemetry, the safety switch, and all kind of things that you need to have when you get started with Pixhawk. So I will take this thing out. So here you can see that we have a Pixhawk flight controller along with all the electronics connected to it. Here I am going to use Raspberry Pi 3B model as my onboard companion computer. The connections are simple, you can follow the documentation for reference. On the Pixhawk you can see telemetry 1 and telemetry 2 port. Telemetry 1 port is connected to the 915 MHz telemetry model of the Pixhawk, and telemetry 2 port we are going to use this to connect with the Raspberry Pi for serial communication. This serial communication takes place via the UART protocol. So UART protocol is slightly different than I2C and SPI protocol. In I2C and SPI protocol you need a system clock along which the data packets are sent, but in UART protocol you don't need a system clock. The data packets are sent with the start and stop bit so that the receiving UART port knows when to start and stop the counting. Just confirm that the connections that you have done are similar to the connections shown here, and if they are okay, then we'll just move on with the next step. Before powering it up, take out all the propellers, and for the demonstration purpose I have kept the Raspberry Pi outside, and this is the connector to which I am connected to the telemetry 2 port, and I'll power it up. So you can see that I'm powering the Raspberry Pi from the telemetry 2 port. Now let's do some settings in the configurations. Now I can access my Raspberry Pi or SSH from my Ubuntu machine, and both Raspberry Pi and my laptop are connected to the same network or the same router. Now we need to get into terminal and SSH pi @ your IP address of the Raspberry Pi. Enter your password, and here we are into the Raspberry Pi. And before this we need to do some configuration settings into a mission planner. For that we can follow the ardupilot documentation for reference. So you need to do these settings here. You need to check that the serial 2 protocol that should be set to 2, serial 2 baud that should be 9 to 1, that's the baud rate over which the Pixhawk and the Raspberry Pi will communicate, and log backend type that should be 3. This thing will need into the future while streaming the data flash log. And once you're done with the mission planner thing, you need to write the parameters and back to the SSH. Now we'll go into the mav proxy documentation. We need to install some Python dependencies and mav proxy and mavlink. For that I'm using here Python 2. For that you can copy this and here we can install them. Before that we'll do So once you have updated your Raspberry Pi, you can paste that command. So I have all the latest versions of the packages. Now next thing is we need to install Mablin. For that we need to enter this command sudo pip install py-mablin. So I have already the latest version of Mablin. Now sudo pip install mav proxy. So here we have done the installation. As I have already all the packages installed, you might take some time for the installation. After this we need to enable the serial hardware port on our Raspberry Pi, and the serial console should be disabled. For that we'll get into configuration, sudo raspi-config, and you need to get into interfacing option, and in that you need to get into serial, and would you like to log in shell to the accessible over serial, so you need to select no. And would you like the serial port hardware to be enabled? Yes. Okay, so now you can reboot your PC for that. After rebooting the Raspberry Pi, I have again connected it over SSH, and the next setting that I'm going to do is very important, because most of the time people fail to figure out that thing, and even I didn't figure out for the first time when I was doing that, and it took me about a week to configure the settings. For that we can follow the UART documentation of Raspberry Pi. So Raspberry Pi 1, 2, 3, they have two UARTs, that is UART 0 and UART 1, and Raspberry Pi 4 has 6 UARTs. So we'll talk about Raspberry Pi 3. In Raspberry Pi 3, the UART 0 is already assigned to Bluetooth. So this means that whenever we'll try to access the serial UART, this Bluetooth will try to conflict, and it won't allow us to access the UART 0. So for that we need to disable this thing, and to disable this thing we need to edit the config.txt file. For that we'll get in the file, that is nano space boot slash config.txt. We'll get to the end of the file. Here the first thing is enable -UART. That was already 0 by default, and I have made it 1 because I wanted to enable the UART port. And the next line, that is dt overlay equals to pi3 -disable -bt. This line is important because we need to disable the Bluetooth. If you are having pi 2 or pi 4, you just need to change that pi3. And after doing this, you can save the file and exit. Now we'll check the list of the TTY ports, because we need to know on which port we are going to connect. For that, ls/dev/tty start, and here we are. So we'll have the focus on this TTY AMA0 and TTY S0. For Raspberry Pi 3, mostly TTY AMA0 is used, so you just note it down. Now we'll move to the final step, so that we can have the connection between the Raspberry Pi and the Pixhawk. For that you need to enter as root user, and here we are. So this is the command that we need to establish the connection, that is mavproxy.py-master and /dev/tty-ama0. So this tty-ama0 is the port on which we are going to establish the connection, and baud rate, that is 9216 and if you can remember, then we have done the setting in the mission planner and set the baud rate to 9 to 1, and here the aircraft is my copter. So if you're having ardupilot or ardusubmarine, then you can just change this. So I'm having a copter, or you can give any name according to your convenience. And when I hit enter, I'll get all the details of the aircraft. So here the mode is stabilized, and I've got GPS log, and I've got the quadcopter firmware version, GBOS FMU V2, and the frame. So you'll get all the information of your drone here. And now if I'm using my transmitter and changing the mode, then we can see that. Or if I want to check the modes, so these are all the available mode. Or if I want to change the mode, that is, I want to change mode land. So now the mode is land. So we can control the drone from here. Here I have successfully established connection between the Raspberry Pi and Pixhawk, and I've got all the parameters from the Raspberry Pi here on the screen. So these are the Mavlink messages that I'm getting here, and I can access my drone right from here without even touching the transmitter. I can change the mode, and I can change any modes. If you are using a transmitter, you are just limited with the modes, but from here I can change any mode at any time. And in the next videos we'll write some Python scripts to autonomously control our drone. Like we can autonomously take off and land, we can use the camera, and we can do some precision landing, or we can just write code in that will autonomously get to the waypoints, and we can do many things. So if you are having any problem in establishing the connection, so just comment down below